This video is on amines. Amines are related to ammonia, NH3, where one or more of the H atoms in ammonia are replaced by R groups. And these R groups can be either carbon chains, rings, or other aromatic rings. The nitrogen in amines geometry is trigonal pyramidal. So what we are looking for with amines is our nitrogen atom. So you can see here is the general Lewis structure for ammonia here. And now what we're doing is we're taking one or more of those H atoms and replacing them. So when we just move to the right here, the H atom that I highlighted there is being replaced by the CH3. CH3 we know is a methyl group. So to name this, we name it methyl and then amine at the end. We will not be using IUPAC names for amines. This textbook does not do that. We will just use the common names. If we replace two of the H atoms, so let's replace the yellow and the orange. As we move right here, that would be the orange replacement, and that would be the yellow replacement. So we have two methyl groups now added to the N atom, so we call this dimethylamine. And if we are going to replace all three H atoms, which I will now highlight in purple, we have three methyl groups, and we call that trimethylamine. Similar to alcohols and other things we looked at, there are types of amines. And that's based on the number of R groups on the nitrogen atom. So if we have a primary amine, that is when we have one R group connected to the N and two hydrogen atoms. That's your primary, and we're always looking at the N here. If you have a secondary amine, you will have two R groups and one hydrogen atom. And if you have a tertiary amine, you have three R groups and no hydrogen atoms. So your nitrogen here will always have, or most of the time, will have a lone pair on it. So it'll always have two dots, and then it'll either be a primary where it looks like this, or a secondary where it looks like this, or a tertiary where it looks like this. And you will see that on the next slide here, the difference between the primary, secondary, and tertiary. So you're locating your nitrogen atom and then seeing how many R groups are on it. So like I said before, we're not using the IUPAC names for this. We're just going to use the common names. So you're just looking at the R group, and then however many you have, either methyl, dimethyl, trimethyl, and add amine on the end of it. So pretty important here that your primary and secondary amines have hydrogen bonding. So that is the strongest intermolecular force. Your tertiary amines do not have that N to H bond. So that won't have hydrogen bonding. Remember, a tertiary has three R groups. So that does not have this strongest intermolecular force. It will most likely have dipole-dipole forces, or it will have dipole-dipole forces, but the primary and secondary have that H attached, which gives it that strongest force. So here we're going to use that when we have to predict the lowest boiling point. But for now it says the amines listed below are structural isomers. If you remember what a structural isomer is, it has the same formula. Structural isomer, same formula, but different connectivity of atoms. Okay, so these are all structural isomers. It says write a skeletal line structure for each. So if we're going to start with A here, skeletal line structure, so we have 3 CH3s, and then we have an N. So this N is going to be attached to 3 C's. So I'm just going to draw an N here, and it's 3 methyls. So there's 1 methyl group, there's 2 methyl groups, there's 3 methyl groups. And then I have to give the lone pair on the N. So that is the skeletal line structure for that amine. If we had to say what type of amine it is, that would be a tertiary amine because it has 3 R groups. And it just so happens that these R groups are all methyls. Right? If we had to draw, that'd be a C with 3 H's, and likewise everywhere else. For B, we have a CH3, a CH2, and then an N, and then the N is attached to an H, and then we have a CH3 attached to that at the end. So if we are going to do that, we would start with our line going down. I'm starting from the right side, so that's my CH3 attached to the N. That N is attached to an H. So I just did that part. And now I need a CH2 and a CH3. So my CH2 is right there. And my CH3 is right there. And my other CH3 is right there. I didn't have to start on the right side like I did, but I just chose to. And then lastly, we want to make sure that N has those 2 dots on it. If we had to say what type of amine this is, that would be a secondary amine. So we said this is tertiary, this is secondary, because the N is attached to 2 R groups and it has 1 H. And then the last one here, we have a CH3, CH2, CH2, and then an N with an H2. So we can draw that. So there's my CH3, CH2, CH2, and now this is my NH2 with my 2 dots. This would be a primary because it's only attached to 1 R group here. And that R group happens to be a propane. Now, predict which amine has the lowest boiling point. Well, remember, primary and secondary have hydrogen bonding. So that makes them have a higher boiling point. It takes more energy to break that intermolecular force. So B and C have hydrogen bonding, which means a higher boiling point. So this guy would have the lowest boiling point because he does not have hydrogen bonding. He has dipole-dipole forces and London dispersion. So that would be the lowest boiling point. So in the pharma world, amines are neurotransmitters. They can be found in the body. They're used in pharmaceuticals. Here's a structure for Prozac. Here is your amine group right here. It happens to be a secondary amine because it has 2 R groups, 1 there and 1 there. And you can see it has, this R group is obviously very large. Alkaloids, here's a vocab word we will see again. These are amines derived from plants. So you can see different things up here. Your tobacco, your nicotine, cocaine is there as well. It's a weird looking structure. Hemlock plant. Your morphine and its derivatives are alkaloids, so your painkillers, all of these are painkillers or opiates. Psilocybin which is the diagram shown below, is an alkaloid produced by various species of mushrooms, and it's known to have psychedelic properties. So it says identify the tertiary amine in this molecule. So I'm looking for my nitrogen atom, and notice I have two of them here. I want the tertiary one, so it should be attached to 3 R groups. So my tertiary one would be right here, with these being my R groups. This one below here, that would be a secondary amine. It says, explain why this compound is an alkaloid. It's an alkaloid because it's derived from a plant. Mushrooms here, or fungus. So amines are weak organic bases. So if you think back to our acid-base chapter, our bases accept a proton, or they accept a hydrogen atom from an acid. So we will see here in this example, if you concentrate on the top one first, we have ammonia, which is our base, and we have water, which is going to be acting as our acid. Remember, that's amphoteric, so that can be either. But look what happens. That water is going to give the H, donate the H to the base, which is going to accept it. Look what the conjugate acid is on the right. Your ammonia, your lone pair on the nitrogen, goes away, and it forms that bond with H. Because ammonia was neutral on the left-hand side, and it gained an H, look on the right side, we now need to put a plus by that N. That N is now positive. And then water turned to hydroxide, and the O becomes negative. Likewise, below that we have methylamine. So here's our methyl group here. So this would be a primary amine, 1R group. And we have water, and the same thing is going to happen here. This H is going to get attached here, and we have our N turning positive. So it's acting as a base. When your amines acting as bases react with acids, you will form something called an amine salt. So amine salt is your products here. So very similar to acid. It is acid-base reactions, but now we're just getting this amine salt as our product. So this says, write the product of the following neutralization reaction. Then label the amine, the acid, and the amine salt. So if I'm looking for my NH group, which is right here, so I know right away that this is my amine. And hydrobromic acid, HBr, that's my acid. So what's going to happen here? This H is going to protonate right here. And that is going to become that looks the same. And now this N, instead of having a lone pair, that's going to have an H up here, and then it's positive. And then for the acid, the conjugate base will just be Br, which now has a negative charge. So your amine salt is both of these. So you'd want to label that your amine salt. So this is a nice table which I like. This is summing up all the functional groups we looked at in chapter 11. So you have your alkenes and your alkynes, your double and triple bonds. You have your aromatic hydrocarbon in this cyclic shape. You have your primary, secondary, and tertiary alcohols. Alcohol being denoted by your OH. And then the primary, secondary, and tertiary comes from the C that is attached to the OH, and you're counting how many R groups are attached to that. So if it's 1 R, it's primary, 2 R is secondary, 3 R is tertiary. You have your phenols, which can be tricky and look like an alcohol. However, this has to be attached to a ring compound. Your thiols are your SH groups attached to an R group. Your ether is your oxygen atom bonded to 2 R groups. And what we just did, your amine groups, we're looking for that N atom, and to determine if it's primary, secondary, tertiary, depends how many R groups there are attached to it.